Hey everybody, the purpose of this video is to help you find some solutions for 2.13.8 in the Collaborative Statistics textbook. In this one they did a before and after study, it looks like. 12 teachers, mathematical problem solving, attitudes were measured before and after. So they took 12 readings beforehand, I guess on a scale of whatever. They didn't tell us that. Let's make it up, say 1 to 10, where 1 you were highly negative towards problem solving, 10 you were amazingly positive towards it, and you gave that number first. Then you took a seminar on problem solving, and then they asked you how you felt afterwards. And it says a positive number change indicates the teacher's attitude toward math became more positive. Interesting. Math or problem solving math. Doesn't matter. We can analyze that later. So in other words, if your post score was bigger than your pre-score, subtracting those would yield you a positive score. So, for example, this 8 right here, they could have come in at a 2 and been like, I hate math, 2. And when they left, I love math now, it's a 10. And 10 minus 2 gives you 8. Whereas this person could have come in at a 5, saying, kind of okay about math, and then left at a 4. So 4 minus 5 gives you -1. This person here came in and left at the exact same score. Before we go any further, I want to make sure we understand the limitations of this kind of data. What kind of data is it? Qualitative or quantitative? I want you to think about that first. Is it qualitative or quantitative data? How many of you said qualitative? How about quantitative? Because you're both right. It's quantitative because it's numbers. Totally. It's numbers. Looks like quantitative data. But I argue that it's qualitative because very often these scales say answer 1 if you're exceptionally dissatisfied, 10 if you're exceptionally satisfied. Well, that's a humongous difference between a number and that. 1 doesn't mean 1, it means dissatisfied. So what does 2 mean? Slightly less dissatisfied? What's slightly less? See what I'm getting at here? I'm getting at here is the challenge of dealing with this kind of data. So in 244 we'll attack this in a different way, but let's just attack it as it is, as numerical data right now, realizing the limitations of the data. Okay, so here's the raw data up top. Here are the grouped, I put them I sorted them into order. Had a hell of a time doing that. I didn't see that second 5 for the longest time, but there's 2 5s. It asks for the average and for the median scores. So your average of these 12 scores is just the sum of them divided by how many there are. And what's nice with 12, you can just sum the negatives, cancel the positives, and what you have left becomes 23. So 3, 2, 1, and 1 is -7. That knocks off these. Adding the rest, you get 8, 9, 17 plus 6 is 23. Divided by 12 gives you ish 2. If you need any kind of precision, it's 1.9. So there's your average. As far as the median goes, I wanted to make sure we remember how to do that when you've got a list of data. The important thing with median, now, of course, you're probably going to be using technology to do this. Awesome. But if you're not, you've got to make sure you sort the data first. Get it sorted. Once it's sorted, you have to find the halfway point. Now, one way is to go directly to it. Since you know there are 12 data points, 1, 2, 3, 4, 5, 6, the median is halfway between the 2 middle ones. So it's going to be halfway between the 1 and the 2. If you can't see that right away, you can do what we did in class, which is chop the low, chop the high, chop the next low, chop the next high, and so forth, and so on, and so forth, and so on, and so forth, and so on. Whoops. And so on, until you get down to 2 middle data points. In this case, the 1 and the 2. So since you have 2, you average those to get the middle, which means the median score is 1.5. Fairly close to your average score of 1.9. So that does get tedious with large data sets, and that's why I'm excited about using technology on larger data sets. But that's a kind of a hands-on attack for a small data set. Hope it helped.